All right, welcome back to tonight's session. So in the first session, we looked at the parabolas. We discussed the parabolas, and in this session, I want us to focus on the hyperbola. Okay. So we looked at the parabolas. Now let's look at the hyperbolas. All right, so before I start talking about the hyperbolas, let me first give you a hint of what they are. So hyperbolas, the parabola was just one curve facing either up or down, and also facing either to the left or to the right. But when we start discussing hyperbolas, we are going to be having two curves on the same XY plane, facing in opposite directions. So what I mean is you have the XY plane like this, and then you have two curves. One is going to be facing this side, the other one will be facing like that. And then on top of that, you need to find the lines of, the asymptotes for these curves. Okay, let me do this. Okay. All right, so I was saying you have the XY plane like that. And then the hyperbolas, these are curves which come out like this. So you have something like that. Maybe you also have another curve like that. And you have, let me draw it properly. You have another curve like that. Then you also be requested to find the asymptotes of this curve. So you find the asymptotes for these curves. So this is how they come out. So you also have another set which will either face up, which will also face up and down. Then you also have to find the asymptotes. Okay, something like this. Let me just display what I'm talking about. So this is one of the examples of what hyperbolas are. So like I said, you have two curves on the same XY plane. One will be facing towards the left, the other one will be facing towards the right. So in other words, they'll be facing in different directions. So this line that is like in the middle of these two curves is the one that is known as the conjugate axis. Then the line that divides the two curves into two equal parts is known as the transverse axis. Yeah, so if you remember very well, when we discussed the ellipse, the general formula of the ellipse was the ellipse with the center 0, 0, the ellipse with the center 0, 0. The general formula was x squared over a squared plus b squared over y squared over b squared is equal to 1. So this is the general formula of the ellipse. But for the hyperbola, you only just have to change the sign there. Instead of putting a plus, you're going to be putting a minus. Yes, so this is how you find, this is the equation of the hyperbolas. Okay, so let's take a look at how to describe the hyperbola. So the other format of the hyperbola is the one that faces up and down. Yeah, so in a similar way with the ellipse, you are also supposed to find the value of A, the value of B, and the value of C, so that you find, these values will help you find or yeah, they will help you sketch the curve. And then C will help you find the eccentricity, which is C over A. C and A will help you find the eccentricity. Then C will also help you find the focus. Then the value of A will help you find the, this one will help you find the vertices. So in this case, we have two vertices. On the hyperbola, rather on the parabola, we only had one vertex. But in this case, we're going to be having two vertices because we have two turning points. Okay, so let's quickly continue. So when the curve, when the curves are along the x-axis, this is the formula. So this is the general formula. Then when the curves are directed along the y-axis, the formula is this one. So now, how do you know that here it's directed in the y or in the x? So you simply just check the first term there. So when you check the term, so if the first term has x squared, then you conclude that the curves are going to face in the opposite directions, but along the x-axis. Then if you find the value of y is the one that is positive or is the one that is the first term, then you conclude that the curves will be opposite and directed along the y, meaning you have something like this. Okay, so that is how simple you determine that's how simple you know whether the curves are facing either whether the curves are directed along the x axis or along the y-axis. Okay, so if they ask you to describe the hyperbola, these are some of the things that you're supposed to find. You have to find the the vertices, since there are two. You have to find the lines of symmetry, which I'm going to show you how to find. So you find the lines of symmetry, then, so the vertices are two, then you also find the foci or the focus. You also have two foci there. Right, so let's quickly move on. You also be requested to find the eccentricity. All right, so how do you find the asymptotes of the hyperbola? So it's simple. When you have the equation is simply just, okay, let me just get one equation. I'll show you the simplest method to find the asymptotes, which you may not find in some books, but it's the simplest. Yeah, so you have the equation. Let's say, for instance, if the curve is directed along the x-axis, if it's along the x-axis, then, or you say the transverse, the transverse is parallel to the y-axis. You can say the transverse axis is parallel to the y-axis or to the x-axis. Okay, let's take this one. Which one should I take? Okay, let me take when the transverse is parallel to the x-axis. So when the transverse is parallel to the x-axis, you expect your curve to come out like this. So if this is the hyperbola that you have, to find the asymptotes, the lines for the asymptotes, you simply, the equations of the asymptote, you simply have to get the equation of this curve. The general formula of this equation is x squared over a squared minus y squared over b squared. And then the other thing you need to note here is that always the first denominator is the one that you get as your a. For the ellipse, we used to say that the greatest of the two numbers is the value of a. But for the hyperbola, you just take the first term. The value of a is simply the denominator of the first term there. So we have one this side. So now to find the equation of these asymptotes, you simply just replace 1 with 0. So we're going to have x squared over a squared minus 1 squared over b squared is equal to 0. Then from here, I'm going to take this to the other side of the equal sign so that I remain with x squared over a squared is equal to y squared over b squared. So now once you have this, you can cross multiply here so that you remain with x this side. I mean, we're finding the equations of the asymptotes. So let's make y the subject. So making y the subject, it means that b squared will come this side so that you have x squared. When you cross multiply there, you have b squared times x squared. You have b squared x squared being equal to y squared. And then when you find the square root of both sides, you expect the values or the solutions to be y is equal to, okay, let me just write it down. So you expect the solution to be y is equal to plus or minus the square root of b squared x squared over a squared. So when you find the square root of this, your solution will simply just be plus or minus bx, we say b over a times x, meaning the first equation will be y is equal to positive b over a times x. The second equation will be y is equal to negative b over a times x. So these are the two equations of these asymptotes here. So this is an equation, or it's an equation of the hyperbola with the center at 0, 0. So now if you have the center which is h, k, you still follow the same procedure, except that you are going to have an equation which will be in the format y minus k is equal to negative b over a in brackets x minus h. If you have the center h, k. So now you do the same procedure if you have the curves facing up and down, because for these you find the equation is y squared over a squared minus x squared over b squared is equal to, so while there is 1 here, you just replace with 0. When you do the cross multiplication here, you find that y squared over a squared is going to be equal to x squared over b squared. Yeah, so after cross multiplying here, I mean, when you take this, you have that. You take this to the other side of the equal sign. Then after cross multiplication here, you have y squared being equal to what? A over b squared squared x squared. Then when you find the square root of both sides, find your y being equal to a over b, I mean plus or minus a over b x. And then if you have the center which is h, k, meaning you have your y minus k being equal to plus or minus a over b x minus h. So these are the equations of the asymptotes. Okay, so if you've been asked to find or to describe the hyperbola, you first have to find the vertices, you have to find the center, you also have to find the center. Of course, if we talk about the center, it's not this point. This point is the vertex. Let me use a different color. So this point is the vertex, even this point is the vertex. So the center is simply just this point here. So you have to find the center, the two vertices, the focus. You also have to find the focus there. You have F1 and F2. You have V1 and V2. You also have to find the center. Then you have to find the value of A and B. Then from there you find the equations of the asymptote. So some books will also ask you to find the transverse axis and the conjugate axis, which is just gotten from the same center there. So the x and y coordinate, you can use those coordinates to find the transverse and the conjugate axis. All right, so let's quickly look at an example. So this is what I was just explaining here. Yeah, so these are equations that I was showing you how to derive. So you can see what we have there. This is the hyperbola with the what's this? With the transverse axis parallel to the x-axis. This is the hyperbola with the transverse axis parallel to the y-axis. So these are the equations of the asymptotes. Remember what I found? These are the equations that I found. So the one with the negative gradient, which is the negative part here, when you have the negative coefficient of x, is the one that has a slant, which is going like this, a slope, which is going like that. Then the one with the slope, which is going up, is the one that has the positive coefficient there. All right, so let's quickly move on. So let's look at this example. So it's a very simple example. Yeah, so it's a very simple example in that the center of this hyperbola is 0, 0. How do I know that? Because I know to say the general formula of the hyperbola is, for this one here, is y minus k squared over a squared minus x minus h squared over b squared being equal to 1. So now if you take this into consideration, and then when you check the equation that has been given in the question here, you find that we don't have the value of k, we don't have the value of h. And this tells us to say the center is therefore 0, 0, because the value of h and k are 0. We know that the center is always in the format h, k from this equation. So now in this case, we conclude that our center is 0, 0 because, our center is 0, 0 because the value of h and k are what? Are both zeros. That's why we had this equation there. So now the center is 0, 0. So now let us find what the focus, the vertices, the focus and the vertices are. So the first thing that you need to do is to create the denominators to a and b respectively. So we have the value of a squared being equal to 9 and the value of b squared being equal to 4. Meaning a here is simply just, when you square root both sides, you find plus or minus 3. Yeah, so a will be plus or minus 3. Then b will be plus or minus 2. Yeah, so, and when you look at this equation, the value that is squared here, the variable that is squared here is 1. Sorry, not really that, but the first term or the positive term in this equation is the term containing y. And if the term containing y is the one that is positive, then we expect our curve to be directed along the y-axis. So meaning our curve is going to be like this. One will face up, the other one will face down. So now, to sketch the curve, we are going to do this. So I'll do a very simple one. So I'm going to move a steps along the y because it's along the y. So the value of a is at the denominator of y. So I'm going to move a steps along the what? The y axis, because along the y axis, but this should be from the center, and my center is 0, 0. So the center is here, and I'm going to move 3 steps along the y. So I'm going to move 1, 2, 3 steps there. So I'll do the same. I'm going to move 2 steps along the x from the center. So I'm going to move 2 steps. So I'll move 2 this side. This side 1, 2, 3. This side 1, 2. So I'm going to draw something like a square, not really a square, but a triangle. Okay. So using this triangle, I'm going to draw the asymptotes. So the asymptotes will be drawn by connecting the corners of this rectangle rather. Okay, so now at these 2 points, this is why sorry, not these 2 points, because it's in the y, so meaning we have the points, one is there, the other one is there. So on these 2 points, this is where my vertices are going to be. So I'll draw the curves like that. And then I'll also draw this side. So after drawing these 2 curves, I now need to find the focus there and there. Then yeah, so we now have to find the focus there and there. So now to find the focus, we need to find the value of C. So the value of C is found by, remember when we're dealing with the ellipse, to find the value of C, we're saying A squared minus B squared. But in this case, we're going to be adding A and B squared. So C squared is therefore going to be 9, because my A squared is 9, and then my B squared is what? Is 4. So it's going to be 9 plus 4. So my C squared is therefore going to be 13. So to find the value of C, C is going to be the square root of what? 13. So here, this is my F1, this is my F2, this is my V1, then we have V2. The center is 0, 0 there. So we can write our coordinates here to show the marker that you know what you're doing. So the first coordinate we're going to write is V1. So V1 is simply just 0, 3. Then V2 is simply just 0, -3. Then we have F1. F1 is simply just F1 is simply just 0, the distance from the center to F1 is equal to C. So this will be 0, the root of 13. Then F2 is going to be 0, negative root 13. So the other thing that you need to do here is to find the eccentricity. So the eccentricity is given by C over A, and C in this case we found to be the root of 13, and then divided by A. The value of A is 3, so you divide it by 3. This is the eccentricity. I don't know if I've forgotten to find other things. Oh, the equations of the asymptotes. So now how do you get the equations of the asymptotes? So this one is along the y. If you don't want to be going through the process of deriving where you equate the given equation, in this case, the equation is y over 9, y squared over 9 minus x squared over 4 being equal to 0. So you equate this to 0, and then you take this to the other side of the equal sign, so that you remain with y squared is equal to 9 over 4 x squared. Then when you square root both sides, you're going to have y being equal to plus or minus 3 over 2 x. So if you don't want to go through this process here, you can simply just master these equations that I showed you here. So when the equation, when the transverse axis is directed along the y coordinate, like the second like the second sketch here, in the case of this situation where you have the transverse axis directed along the y-axis, you have a curve, the hyperbola, which is in this format. So for this one, you use this point number 2 here. So use point number 2, meaning the first equation would be y is equal to a over bx. So what was my a in the previous question? My a was equal to 3 and my b was equal to 2. So you simply just say y is equal to 3 over 2x. Then to find the other equation, you say y is equal to -3 over 2x. That's if you don't want to go through this process of deriving. So that's the simplest way to find the equations. So meaning you have to master these 2 points here. So we have point number 1. You have to make sure that you master this part and that part, and then after mastering, I think that was supposed to, this one was supposed to have a negative, even this one. So when you master these, you also have to know that, okay, for this one only applies when the parabolas are directed along the x, and then this one applies when the parabola, the hyperbolas are directed along the y. So it's as simple as this. Let's quickly move on to the next example. So as you can see, this is what I was just trying to illustrate. Okay. Okay, let's look at the hyperbolas with the center h, k, which I believe I've already talked about. But anyway, we'll have to do some examples for proper understanding. So we have this, we have this equation. I think I talked about this equation on the previous slide. I even wrote it down. So you have this equation. Now, since the positive part of this equation is x, so you expect our parabola to either face this side or this other side. I mean, this and this other side. Then when the value of y is the one that was positive, meaning it was the first term, in the case where it's the first term, meaning the hyperbolas will face up and downward. Okay. So now let's so in case you are told to describe a hyperbola, which is in this format, you find the center, which is the center is going to be h, k, and then you also find the vertices. The focus also has to be found, and the vertex there. Same applies to the other hyperbola, the other parabola this side. Find the vertex, focus, and and then you also find the equations. Remember what I told you about adding k and h in the equations. So this is what you do. It's very simple. Let's look at an example. So in this case, the transverse axis is parallel to the x-axis. Yeah, so to find the focus, you say h, meaning the x-coordinate plus the value of c, comma k, then the h-coordinate minus the value of c, comma k. Okay, I'm rushing to, I want us to do at least one example before we end the meeting. So we have that equation there for the asymptote when the transverse axis is parallel to the x-axis. Then you have this equation when the transverse axis is parallel to the y-axis. Okay, let's look at this example. I just want to check if there's another example. Okay, there's no example. So this is the last example we're doing tonight. So I know we all know how to complete the square. So let me just keep this part. I'll write it like that. I'll do that. So in case you don't know how to complete the square of this equation, you should just inbox me. I'll send you a video where I did the completing of the square method step by step. At least you should learn how to do it on your own. All right, so this, I'm just interested in the final equation which they found here. So it's y minus 3 over 4 and x minus 2 over 9. So we have, I've forgotten, y minus 3 and x minus 2. So we have y minus 3 and x minus 2. Let me just write them down. Y minus 3 squared over 9 minus x minus 2 squared over 4 is equal to 1. Just want to confirm. All right. So the first thing that you do is to find the center. So the center of this hyperbola is you equate y minus 3 and x minus 2 to 0. When you equate y minus 3 to 0, you find the value of y to be 3. When you equate x minus 2 to 0, you find the value of x to be 2. So you find that the center is 2, 3. And then after finding the center, you have to find the values of a and b. Remember what I told you, a is always the denominator of the first term. So the first term that we have here is 9. So we say a squared is equal to 9, meaning the value of a is 3. Or you can say plus or minus 3. Then to find the value of b, the value of b, you equate the denominator of the second term there to b squared. So you have 4 there, meaning the value of b is plus or minus 4. Oh, sorry, plus or minus 2. Okay. So after finding a and b, you can now find what c is. C will help you find the focus and also the eccentricity. So we know that c squared is equal to a squared plus b squared. So our c squared is equal to, the value of a squared is 9, the value of b squared is 4. So we say 9 plus 4. So our c is therefore going to be the root of 13. So after finding a, b, and c, I think we can now do a sketch. So we know that since y is squared, we expect our curves to face up and what? And down. So we are going to draw this XY plane. Then we move how many steps in the a-axis, in the y-axis? A squared was 9, so we move a steps in the y-axis. So a is 3. So I'm going to move 3 steps. From what? From the center. So you should always know that you are moving away from the center. So the center is 2, 3. Let us first locate our 2, 3. So say 1, 2. So 2, 1, 2, 3. So we have 3. So this is my center. So I'm going to move 3 steps from the center going towards the y-axis. So I have 1, 2, 3. So I have 6 there. I have 1 point there. Then I'll move down 3 times as well. 1, 2, 3. So I have another point there. So I'm going to move B steps along the axis, the X. So we have, so in this case we have B as 2. So we have 1, 2. So I have 1 point there, 1, 2, another point there. So I can now draw my dotted box. So I'm going to draw a dotted box there. After drawing a dotted box, I have to draw my asymptotes. So the asymptotes are supposed to pass through the center. So I'm going to draw my asymptotes. So after drawing the asymptotes, I know that the curves are supposed to face up and down. So I can even do the simple sketch there. So even this side, I'm going to sketch. That's to 10 at this point. Okay, so after doing the sketching, you can now find what else? The focus. So you just add the value of C to the center. So in this case, I'm going to be adding to the y coordinate because I know that if this is in the y, the value of x is constant. So in the y, the value of x is constant. So where is my center? My center is this one. So we are in the y. So the value of x will be held constant. And then we add the value of c to 3 and subtract from 3. So we say 3 plus the root of 13 gives us the focus there. So the first focus will be somewhere there. So first focus F1 will be 2,3 plus the root of 13. And then the second focus will be somewhere there, which is F2, which is going to be 2, the root of what? 3 minus the root of 13. So that is our focus. Then the vertex there, the vertices, we have V2 there and V1 there. So V1 and V2 are simple. You just get the normal coordinates. You have 2, 6 there. You have 2, 6. Then you have 2, 0. So here you have 2, 0. And then what else is remaining? I think everything is done. Oh, the lines of symmetry. So how do you find the lines of symmetry? Remember what I told you. You can either refer to those equations that I showed you, or you can simply just equate the equation that you've been given, in this case is this one, to 0. So you're going to have, if you equate this equation to 0, you're going to have y minus 3 squared over 9 minus x minus 2 squared over 4. So at the end of this slide, there's an exercise which you'll be required to do. So after doing the cross multiplication there, you are going to have y minus 3 squared being equal to 9 over 4 x minus 2 squared. When you square root both sides, you have y minus 3 being equal to plus or minus 3 over 2 x minus 2. So these two are going to be your equations. So the first equation will be y is equal to 3 plus 3 over 2 x minus 2. The other equation will be y is equal to 3 minus 3 over 2 x minus 2. So these are the two equations of the asymptotes. Of course, the one that has the negative gradient, this one, is the one that you give to this line here, this line, because it has a negative gradient. The one with a positive gradient, this one, is the one that you give to this line here because it has a positive gradient. Do you have any questions? So there's an exercise at the end of this slide. So make sure that you do the exercise and submit. I'll make sure that I mark the previous exercise tonight and send to you. So just text me on WhatsApp if you send me an exercise so that I begin to mark right now and forward it back to you. So you should also ensure that you do this exercise and submit. All right. So if you have any questions, I'll ask you to join again. If you have any questions, I'll ask you to join again.